let's go start with a bit of an introduction for me, I guess, to you guys. So I've been an engineer for a while now, I guess. I've been a manager, engineering manager, for not quite as long as I've been an engineer, but I've done a few bits and pieces. And now I head up the engineering team at Codat, as Luke said, sort of a London-based fintech. I think sort of 35 engineers in QA now. I've pretty much always written enterprise code in .NET. Earlier in my career, I started electronics engineer, and I had a little bit of time in sort of firmware and wrote some C for embedded devices, but generally sort of enterprise C#. And so this has given me a bunch of biases. So, you know, this is a .NET group of people, so you might have similar biases to me, so they might be helpful. Might be things you recognize, but yeah, just to bear in mind, I guess that my perspective is very much shaped by those experiences. So again, I'm not the cleverest person in the room, just the one that happens to be talking about something. So I hope that some of this is kind of insightful. Maybe it's some stuff that's new, maybe it's some stuff that you're familiar with, or maybe you have a depth of knowledge that I don't. So yeah, really interesting to hear from people if you've got things to add. I think doing a chalk and talk thing is nice, but hopefully there'll be a bit of time at the end for some sort of conversation and some questions and things like that around the topic. So first of all, I'm going to introduce this thing called the Boring Technology Club, which was sort of presented by this guy, a bunch of Medium posts and blog posts by Dan McKinley. That's his Twitter handle if you want to go and find him. And you can go to theboringtechnologyclub.com. And he did a bunch of talks about boring technology and why you should choose boring technology and why that's important. So for those of you who may not have heard of this before, I'm going to kind of do a brief synopsis of what the Boring Technology Club is all about. And disingenuous to say it was something that I invented, right? It's Dan McKinley's thing, but it was the basis of thinking for this talk, and in terms of the way it defined it as, you know, this club, I guess. But it was some things that I think I'd been thinking about for a while in the .NET space, and when I, you know, especially when I was in the front end world, it seemed to be a useful thing to think about, and it may be something that, you know, you thought about in your own organizations as well, and maybe didn't know that there was a label out there or a group of people that talked about it using this sort of jargon. So some of this might be familiar, and if not, I hope it's useful. And then if you want to go and do a bit more reading, that's a good place to go and look. So I guess the question that it sort of posits here is, you know, what technology should you choose, and how do you keep developers happy, and what are the weights and balances between these two factors in terms of your decision making as an engineer in any organization, right? Not necessarily an architect who's making some ivory tower edict. You know, everyone who makes choices decides to use some NuGet library or not, right? You're always making choices about technology and trying to balance these kind of things. And so the answer generally in a lot of teams, definitely from a lot of engineers, is shiny, new, cool, fun things that are definitely better than the old thing that we were using. So this might be, you know, the latest in persistence, or a language that looks much shinier than the language that you're using, or that new JavaScript build tool that looks better than the one that came before, or whatever. And sometimes this is cool, right? This is how a lot of us learn to expand our knowledge, you know, and learn about new ideas and principles. Often comes from picking up a technology that's completely alien, or picking up a language that's completely alien. And I think that's really good in a lot of ways. That's not necessarily what the Boring Technology Club is trying to get at, right? It's not about education necessarily. And so I've just thought of this point, which is something that happened to me recently, right? Which is I know enough about the quote, so I'll say it out loud. I know enough about quantum physics to know I know absolutely nothing about it. But I've tried often to do the plumbing in my apartment, or I recently tried to do some plumbing in my apartment. And because I didn't really know that I knew nothing about plumbing. This is true of a lot of things, isn't it? That people say that you only really know something if you know that you don't know that much about it. You know, there's bliss in ignorance. So in terms of like technology choices, we've got two factors that are kind of maybe pointing in terms, you know, when we're making choices about choosing technology for, you know, for business code that we're writing. We've got the velocity value, aside from the developer happiness, you know, that we just talked about, that kind of new shiny things. So we've got the velocity value and the maintenance value. So there's some thesis, you know, there's some assumption made at the beginning, some hypothesis that the technology that you want to choose, or that you're looking to choose, or that you're looking to change, will improve some aspect of your velocity, right? So I will be quicker at being able to build products, or I'll be more accurate and prevent rework by using some particular technology, this velocity value. And there's the maintenance value, right? So how much is it going to cost me in terms of time to keep this technology in production and keep it running? So the first one, right, you're probably thinking it's kind of short-term negative, right? Your kind of brand new thing, it's maybe going to take you some time to get up to minute to get up to speed with it, but then it's going to be the killer thing, right? That's going to make your performance 10x or whatever. And then the maintenance value, right, which again, you think is short-term negative, and then you hope the maintenance cost gets less rather than more, ideally. Of course, it's never free. You're never going to get free maintenance, which means that hopefully it's never going to slip negative. I don't know of any system that maintains itself the longer you've been using it, but maybe that's because I haven't been looking in the right places. So, you know, these two values over time, you know, you sort of have to integrate them. And surprisingly or unsurprisingly, that I think most of us would probably be, you know, be fair to be honest in saying that generally the term that dominates this equation in terms of the balance of velocity minus maintenance is that the maintenance is always more, right? That I generally trying to keep something running is more expensive than the difference in using any particular technology in terms of its increase in velocity for your ability to kind of get stuff done with it. And this means that it's an important factor, a very important factor to take into consideration when choosing a technology that you're going to adopt and kind of run and operate in production, not necessarily a technology they're going to get and use to learn about something. And this is kind of the driving force for the Boring Technology Club. This is kind of, I guess, what he's talking about, and it's worth going and looking at, you know, the post detail about some of the ways that he breaks that down, about why that term is always likely to dominate. So there's something else that is kind of floated here, like a get out of jail free card, which might be what he would have called it maybe if he played a lot of Monopoly, which is this kind of innovation token idea. This is that, you know, whenever you want to do something that's new and uncharted, you kind of get this ability to be able to spend something in your organization. Whether that's, I think that in terms of reducing the time to get the good velocity value, reducing the maintenance value quicker, you know, if I spend some time researching, reading, doing spikes, you know, working out how to use this thing, we might get to that velocity point and that low maintenance point quicker, and you can kind of spend some of these tokens and time. They can't constantly be spending innovation tokens, right? You know, you can't this week be learning everything there is to know about replicating Mongo globally, and then next week think, oh, I want to learn all about how to do coroutines in Go, and then the week after being like, actually, I think I prefer the way Rust, because if you're in a constant cycle of learning, then you're not necessarily getting a chance to apply it, and then after applying it, seeing it operate in production, and, you know, seeing some of the deeper usefulness, I guess, out of it, because it's operating something in production over some time that's hopefully getting your company some revenue. And you can spend these sort of tokens. Let's say we can spend these tokens on a couple of different things. You can spend it on the business case. So doing something that's new and uncharted in terms of what you're doing as a business versus the technology you're using to solve that problem. Right? It's rare that you're going to be, that it's sensible advice to try and spend a token on both at the same time, right? To do something that you've never tried to do before using a tool that you've never used before, right? Probably not a good idea to be going under both of these unknowns. And actually in a lot of businesses, you know, as engineers, we're there to be solving problems. You know, a lot of businesses that people are working on, especially if you're working kind of startups and things like that, actually you're spending a huge amount of innovation tokens already on the business case. Hopefully you're trying to do things that people haven't done before. And that takes a lot of, you know, mental capacity and experimentation and all that kind of stuff. That takes time. That's time that's kind of reducing your, you know, supposed velocity to get product there. Quite often the point at which we're thinking we want to start accruing some extra bit of stuff, maybe some velocity out of something is when it's been running in a way that we know where maybe the bottlenecks are, where the things are that need to be improved and why they need to be improved, whether it's the developer experience in terms of, hey, it takes 2 hours to build our application in Rust and we've got 20 developers all trying to build pull requests, maybe we should switch to a different technology that means our build times are less, the developer experience is better. Or maybe it's like we've hit the absolute bare bones metal limit of some data persistence error or some IO thing, and you're like, okay, we need to use some sort of fancy network stack to be able to improve maybe the perf of IO. Yeah, so that's that kind of that other side of it. So this ability to kind of picking technology on the basis of your ability to ensure that the balance between its speed of either this velocity impact, so that's either velocity of like developer experience or maybe system performance, versus the kind of innovation tokens and maintenance cost rather, and then the innovation tokens to kind of balance. So yeah, the important thing here to note, and I guess I was alluding to it a bit in those things, is that this isn't necessarily, like I said, about, you know, choosing a technology on the basis of building an understanding and learning that might broaden your horizons to make you generally a better engineer, right? Learning a functional programming language to make you think differently about programming. This is about writing software, business software that's going to be put to work in your company, and hopefully be adding for that company's ability to make revenue, and that revenue then kind of being able to pay your salary. And this goes counter to maybe some of those ideas of always picking the right tool for the job is maybe broader than just, oh, we're using this architectural pattern. This architectural pattern means we should use this data persistence technology because, you know, it's a document DB and this thing is a document, if you've never run a document DB in production before, because maybe that's going to impact that maintenance cost and your ability then to kind of sell product to make revenue. Cool. So I've got a sad story on the basis of kind of an antithesis to this posit. So I'm going to go through like an example, basically, a sad story of not picking boring technology. So at Codat, we operate at reasonable scale with data. We crunch, you know, gigabytes, terabytes of data a day. Most of it's mapping JSON to JSON, while we standardize kind of business management accounts and things like that, which is a big part of what Codat does. And we had in the middle of it this big data cache for what we call contributed data, which is all the data that we're standardizing. And this thing was written in SQL. It was written, the data schema was kind of written in haste in the first 3 months of the organization's history. It grew rapidly in terms of the amount of data that was being put into it, the amount of load that was being put into it. The schema got bigger and bigger and bigger, and not necessarily designed by specialists, designed by engineers who weren't necessarily the best SQL engineers. I mean, mea culpa, I include myself in that, wasn't necessarily the best SQL guy in the world. and it started to grow and to get a bit clunky. And we started noticing lots of performance bottlenecks. We were using primary keys, GUIDs as primary keys, for, in one instance. This led to massive fragmentation in indexes and things like that, which might not necessarily be that bad, but we were doing a huge number of write actions, and so lots of data was spread over large numbers of pages that were very fragmented quickly, and that did start to impact performance. What we were noticing is that I would run something to clean up the fragmentation of the indexes, rebuild indexes, and then a couple of days later it would be getting slower, and then by the time we got to Wednesday after the Monday of running the rebuild, with the database would be grinding to a halt again. We knew that there was a problem with the schema. There was a problem with the way that we were writing to the database, how much we were using .NET to do the work that actually set theory and SQL would be better at doing, and maybe we could shift things around. So we went to look out for the market, right? What can we do to fix this problem? And it seemed like Cosmos DB gave us the best of both worlds. We could query like SQL, and we could write like documents, and using this technology seemed like it would be a great thing, to solve those woes that we had without ever having to actually tackle directly the woes that we had. And obviously what quickly then happened is we realized that as soon as we started running it in parallel with the system we had, and started doing all sorts of more serious things with it in production, the way it behaved was not something that we necessarily had good comprehension of. Our assumed sense of that second term, that maintenance term, was very much affected by the marketing and how-to guides that we were reading to be able to work it. But actually building up operational experience was something that we were doing on the fly, while we were firefighting, and it was hard going. In the end, what we did is, as we realized that that came to a head, there were a number of features we were doing. We needed support on our API into the kind of app that served this data, in terms of paging, that it turned out Cosmos DB could handle, but it would cost huge amount of money, which was not ideal. And so we had a risk of kind of swallowing the business under the operational cost of Cosmos DB. So the reality is this kind of statement, right? Maybe it's obvious, right? Operating systems at scale is actually really hard. And so that operations point, right, that maintenance point, is not talking about maintenance in terms of just code. We're talking about maintenance in terms of the ongoing operations for that piece of system. And doing that at scale, doing that at production, is much, much harder than people often give themselves credit of the technologies they already use. Whether that's a SQL DB that you've been messing with SQL for 10 years, and even if you say you're not a great SQL guy, right, I can still look at a query plan and sort of understand, or I can still look at the sys tables, and importantly, I can go onto Google and I can Google pretty much any problem for SQL, and somebody will give you a block that says, run this query, it'll tell you exactly what's wrong, right? Because it's been around for a while. And so, I talked about biases again at the beginning. There are positive and negative biases, and sometimes people discount those ones where it's like, hey, I've got a whole bunch of knowledge here built up over time. There's a lot of cultural knowledge built up over something at time. It's not worth necessarily discounting that, even though it might seem boring. So anyone was born in the mid-80s might recognize this 90s pop band. This is Steps. Are singing in a costume, singing the song "Better the Devil You Know," which I think seemed like a relevant gag for this point. So the idea of kind of being swayed by those terms, that implied sense of your increase in velocity versus the reality of that maintenance term, it's quite sometimes not as obvious when you're first reviewing maybe a new technology as people give themselves credit. And so there's a sad story to corroborate that. So the one thing about the Boring Technology Club that Dan goes into in quite a lot of detail is that you want to choose boring technology. Boring technology is worth choosing because of all these reasons. Better the devil you know, and these costs associated with with some new piece of tech. But one thing it doesn't really go into is how you might assess what is and what isn't boring. What's boring to you, and what are the terms that you should be maybe thinking about that will help you understand whether or not a technology or some choice is boring to you as an organization. So I spent some time trying to think about what are the measures and things like that we might use to and where do we want to get those measures to come from. And like I say, this is still an early progress, so it's not fully formed, and I'm still really interested to hear people's opinion and get feedback on these concepts as we go through. So so what are these terms that kind of, I think at Codat we like to think of as things that kind of go in to make this this index, right, of to give some score to some technology about how boring it might be. So my first index, my first factor in the index, the first thing I want to measure is like staying humble to your knowledge and ease and ability and the humility of the product. So one of the things I sort of thought about here was how do you know? So maybe this is a bit tongue-in-cheek compared to some of the others, right? Is it easy to find articles online that talk at detail about how awful this technology is, right? If a technology has got to a point in which people have been operating it in enough ways in production and at scale that they've had the ability and the time to sit down to write and rant for 3 pages on a Medium article about exactly why you should never choose this technology, then it probably shows a certain degree of maturity of the technology. If people have found the ghosts in the closet. The other thing is, in terms of staying humble to the technology's failings, it's almost more important to know. It's more important to know, I guess that's harsh. It's incredibly important to know before you make a decision both sides of the consequences of that decision, right? So there's always going to be positive and negative consequences to the decision, and it's very easy at times when you're trying to do something, make a decision to move forward, you're going to concentrate on the positive side of those consequences, right? Because that's why you're doing it. You wouldn't be making that decision if you weren't looking to gain something from making the decision. But for any decision that's got a whole bunch of positive sides, there's always going to be a whole bunch of negative consequences to that as well. So it's always worth balancing those two and understanding, okay, what do we discount by making this choice? What is this thing not capable of doing? Even though maybe these are the bases that we cover it, because it's very rare you're going to find something that says this is in every way 100% definitely the right decision. I'm not saying that those things don't exist, but there's nearly always some negative impact maybe. And so it's worth spending the time kind of researching, assessing, and understanding what those might be for technology. So try and keep the technology humble. Don't necessarily read marketing material or take all of your advice from the vendor as well. Another useful point maybe to that point is, if you're looking for articles about how awful the technology is, the likelihood is you're finding articles written by somebody who isn't a core contributor to the open source project, or isn't somebody who runs or works at that organization. They're going to be somebody who's kind of doesn't necessarily have an axe to grind other than their own interest in their operation of that tech. Cool. So maturity, I took a finger in the air guess in terms of talking about those innovation tokens to balance this against it. So the maturity of the technology, is the technology younger than your company? I think that seems to be, to me, it felt like a sort of a fairly good rule of thumb. If you're an early stage company, the likelihood is you are innovating a huge amount in the business case. And so maybe you don't want to be spending time trying to innovate on the technology case. Obviously, as your company gets older and more mature, the likelihood is if your company has survived, it's probably got some form of revenue generating product, and that revenue generating product for everybody probably in this room is a piece of software, which means that software has some sense of maturity, which means you probably know where your velocity drag is, right? Whether it's the developer experience for the stack, or whether it's the performance of the stack, whether it's the cost of the stack, all of those sorts of things. And so making sure you're judging a technology with its maturity, not just based on how long it's been knocking around or how many stars it's got on GitHub or when the initial commit was, but on the basis of its maturity relative to your organization, because I think that's quite important. And maybe that would be the same for a project, right? If you've got a team, maybe you've got a company that's 200 years old, but the team and building the product and the organization that's building the product inside that company maybe has only been around for a few months. So again, you know, how much have you got in terms of wiggle room to be able to spend on innovating where? And that might change where you balance your weight, or you balance your measure on your boring index. How boring is this technology? Might be balanced on the basis of maturity for that reason. You know, at Codat, early doors, you know, we picked SQL and we picked .NET because everyone in the company, there was 4 or 5 of us at the beginning, and 3 of us wrote code, that we'd all used those tools before. And so we weren't thinking, you know, we weren't going to be trying to learn how to use the technology in the months at which we were trying to first build the systems. Whereas now, you know, a few more years down the line, we've got a number of systems that operate effectively and at scale, and we have an ability to be able to say, okay, where we know the bottlenecks are, in which case, where can we incur that cost for maintenance on the basis of whatever improvement we want for velocity. Cool. So maturity. Mentors. So this goes to, I guess, I mean, they're all somewhat linked, right? I don't want to kind of reduce these to the absurd. You could probably put them all under one blanket if you wanted to, but I think mentors, you know, similar to maturity, I guess, is there people in your organization that have used the technology in production before? And obviously you might think that, okay, maybe that discounts everybody in the world from ever using a new technology, because who's going to be the first person? Well, okay, maybe you can spend an innovation token on the fact that you don't really have mentors for the technology. This might also be that, you know, maybe a core contributor is somebody that works for your company, and so in terms of someone who's been using it in production, that's, you know, you're building it with that individual in mind, or, you know, with the technology being part of your product repertoire in mind. And generally with most sorts of things, this is kind of having the sage in the room, right? There's someone who's kind of experienced that bad as well as the good, the realities of operations. And it's important having someone in the room to go and ask questions to, not necessarily because they know the answers. And I think that's a very important thing to recognize about mentors in any space, is that they're not necessarily going to be the people that can give you the right answer straight away, but maybe they've got visibility and perception of things in order to know where you should be going to look for the answer that you're kind of trying to find out. Maybe somebody that wants to kind of to do that with you. And so, yeah, it's important to make sure you have those sorts of people. Oh, that's neighbors. So yeah, it's important to have sort of people around that that be able to signpost and help find answers to questions you might have, you know, when you need to find them. Cool. So yeah, mentors. The next one is AOE, which anyone who's played a lot of role-playing games or tabletop games or whatever, right? So area of effect. So what's the blast radius for this technology? This is really important in terms of all of the other things are about finding a piece of technology that in the world has good operating experience, then kind of mentorship, right? Finding someone local to you that's got kind of operating experience. And then this kind of blast radius is about allowing you to learn operational experience with a piece of technology in a way that's kind of got a safe failure mode. So, you know, are you thinking, and this goes to the sad story that I mentioned before, you know, is the system that we chose to use this new technology was a core part of the system that basically every user had to use every time they interacted with our product, which means the blast radius was total, right? It was the entire product was covered by this blast radius. And really what you want to do is, while you're learning operations for something, you want to make sure that it has a safe failure mode for anything that might go wrong, to allow you to learn fast, or to try and learn as fast as you can in that situation, right? The last thing you want really to be doing is trying to learn while firefighting, or doing all of your learning during firefighting, because quite often what happens then is the fixes that are put in are put in in haste. And then what you find is maybe 18 months down the line, people are looking at this technology going, the technology is rubbish because of all these plasters that we've got covering it, right? All these bandages that cover this piece of technology, or our implementation of it. When really, I think if you have an opportunity to take a step back, think about the way that your implementation is on the basis of learning from that operational experience, it might be that actually it's your implementation of the technology that is potentially flawed, and not necessarily the idea that this thing covered in bandages is fundamentally broken. So it's important to make sure that when you're testing something new or going for something new, that you kind of minimize that blast radius. Now, this might be that you run it in parallel with a system with a feature switch. We did do that with Cosmos, and one of the reasons why we were quite lucky in that we could then backtrack. We were running them in parallel, which we could afford to do, and not everyone can afford to do that. It turned out we maybe couldn't if we'd carried on. So yeah, I think that's incredibly important. Is often, going back to that other point that I talked about the kind of maturity of technology versus maturity of organization or product or project, is if you're looking to use a brand new technology to make some velocity gain on something with a large blast radius, or with a rapidly changing business case, maybe find somewhere that's a bit more stable in terms of a small chunk of your business that's operating and is fairly stable, to then be like, this is a space that maybe we can innovate on the technology, and we can use those learnings. We can build up a number of internal mentors maybe, that then kind of lower the cost, make a technology more boring to the organization, and lower the cost of maintenance for those velocity improvements, to be able to then maybe apply to a much larger section of your product that's maybe got a much bigger blast radius. So yeah, area of effect, another important thing. So the final point here is cost. As I said, the goal of engineering, right, is to be building products that then can be sold by the organization to make revenue for us all to get paid a salary. And so it's important to have a recognition of operating cost in terms of the technology we're choosing, before that becomes the limiting factor. A wise person once said to me is the worst thing you could possibly be is frightened of success. Right, what if this product does really, really well? If you have an operational cost, I've said here, if your load increases linearly, does operating cost. Hopefully less than, it doesn't match, it's not linear, right? Hopefully your operating cost doesn't exponentially go up with load or something like that, right? Because then you might get into the sort of niggling position where, the cost of the system, running the system, is starting to overtake, and then you start being frightened of success, right? Oh, if every one of our users started using this subsystem, the load would destroy X system, and the cost of it would be so great that essentially we'd be paying our customers to use the system. So that's that kind of worst case scenario, but it's always worth testing, and that goes to the blast radius as well, right? Where you've got an area in which you can closely monitor something in a small blast radius to understand the cost implication. This is something that's probably more relevant to organizations that are running systems predominantly in the cloud, where there's much more of a kind of pay-as-you-go type model. to using systems. I know with a lot of other systems, the kind of balance of what would be cost maybe in a cloud system is performance, right? Performance of a system drops as the load increases to a point where you've then got to make a decision about dropping some capital on, you know, another machine on a stack or something like that. So I mean, cost is different in those examples, and in terms of the way it might grow for a cloud system is maybe something that it needs more close monitoring because it's not always as easily limited. And obviously, often the joy of using something in the cloud is the whole point is you're supposed to be able to just let someone else handle certain issues with scalability and things like that. But again, as engineers, maybe this is something that a lot of people kind of maybe don't have a handle on, and maybe don't necessarily have the hooks into. But it's always worth understanding, I think, for anyone, because you know it's people talk about business problems versus technology problems, and I don't know whether I kind of agree with that thinking, in that the engineering is part of the business, right? We're all members of the same organization, and whether you're a salesperson or an engineering person, it's all business decisions, right? Because we're all trying to sell better products to make better revenue to hopefully get pay rise, maybe. So yeah, having an understanding of the implication of ongoing cost. Again, that maintenance cost starting to override any increase you're starting to feel with velocity. So some final points then in terms of how the index relates to, or this idea of indexing these technologies relates to innovation tokens, is though I would suggest when you're working out your weights and measures and where you want to be able to spend innovation tokens, you're using those to mitigate those factors. So things like, can you stand to be an early adopter? That's that maturity and mentors thing. Can you spend the money on maybe sending people on training courses, getting a good relationship with the core contributors if it's an open source project, for them to allow to support you as a team in kind of learning how to use the system. Same for finding a center of excellence for good training on a system. So you're not necessarily trying to learn directly from the textbook, because a lot of things with learning, there's a lot of really great material out there, but it's quite often learning on your own is hard, and you might necessarily miss the fastest route to certain pieces of knowledge, or certain concepts that maybe are non-linear in terms of the dimensions for learning, which means that kind of knowing where you need to be going back to be able to relate information is not very easy when you're reading something like, even with hypermedia on an API docs, right, you're still reading fairly linearly, and sometimes it helps to have someone be able to explain things in the terms that that you might better understand, right? The API docs and documentation has to be very catch-all. Can you run the new system in parallel with the old one? That again goes to blast radius and cost. Can you afford the cost of running them in parallel, so you can do feature switching, let one set of customers use one, another set use the other, and measure, making sure you're getting that velocity increase that you can, learning about operations with a smaller blast radius. Again, the war chest in terms of swallowing a margin of rising costs in the cloud, maybe, which can afford you the time to learn how to implement it in maybe a more cost-effective way. Cool. So yeah, those are some pieces about innovation tokens. I think there was another point that oh right, yeah, sure. There's actually another slide, a whole slide for it. Right, when to spend. So this is the other thing I would suggest, is in terms of when you think you can swallow these things, from my own experience, and I guess from my own research, I don't know whether this is explicitly called out by the Boring Technology Club, is I would always suggest that you need to be spending your innovation tokens in your industry before the release date, right? You need to be assured that these are things and time that you can sacrifice, and generally it's time that you're kind of, maybe money that you're sacrificing, is spent before. As I mentioned before, that kind of idea of firefighting during an incident, it doesn't necessarily give you the opportunity to take a step back and think about your implementation, which might need rework. That rework needs to be planned accordingly, and you necessarily want to always be doing that during an incident, while you're trying to operate a system. SRE, obviously, I said here, that's why we have SRE, right? Because firefighting is always going to be going on. Not saying that you're going to get to a situation where you've spent some tokens, you've all been on training for 3 months, and then you know exactly how the system's going to behave in every dimension when you get it in production, and it's always going to be fine. There's always going to be operational stuff going on, but it's about like how much risk, how much downtime, all those sorts of things are you willing to stomach? Are you willing to stomach an occasion where, okay, we've released this thing to here, we don't really know what happens necessarily when we scale to this level of of people that we might have in production, some system or some change that's coming up that might impact the way that we use something, that then might constitute, oh, actually what we need is 3 weeks of rework. We need to fundamentally change the way we're interacting with this system, which you can't necessarily do if it's an incident that's causing downtime today. So yeah, the other point, I guess, and this goes to maybe just a mantra that I think I would put on any slide in any talk I ever gave to anyone. It's about kind of role-playing incidents and doing 3 amigos for architecture and technology selection, just as you would for a user story anywhere, right? It's important to make sure you're acknowledging positive and negative consequences of those decisions, so that you have sort of playbooks that say, okay, we've done as much testing for this technology, we've used it in this blast radius, but we don't know necessarily this, and this, or and we don't have a direct dash, we don't know how to build, we haven't got the stats to build a dashboard for this thing. So we think that might be a problem, but we can't necessarily alert on it, whatever it is. Make sure you're role-playing incidents before stuff gets into production. Cool, so weights. This is the final thing, is each of those measures that we talked about, how you choose to attribute a number to them, of course, may be weighted slightly differently also for any team. So it's important to acknowledge those weighting differences within an organization. It might be that as an organization, different teams actually can see a technology as being slightly less or more boring than any other. And that's another thing that's worth kind of taking into account, to make sure that not all implementers of things are equal in terms of what technologies they might be choosing to test out somewhere. It might be that okay, one team's assessed that this technology might give all these velocity improvements, but maybe that team isn't the right team to be taking that on board at this time. Maybe it's worth finding out if there's someone else you can kind of build up that knowledge. Now, if you're an engineer in any particular team, that might be doing stuff from the ground up, right? Talking to peers about things you found, giving internal talks, being honest about those positive and negative consequences. I think this is really cool, but I've never operated like something like this in production. Is there some other team because we think we'd get these benefits, and making sure that you're talking about those things, because otherwise, yeah, I guess maybe people aren't necessarily going to recognize that there might be a potential velocity gain in your own team, even if you don't necessarily feel like you've got the innovation token to spend on adopting it. So the example I've given here is maybe a small one there. If you've got some team where maybe the 4 engineers on that team have all coded in 12 different programming languages, I've said 3 languages, including a functional programming one, and they've been doing that for some time. It's not just JavaScript, HTML, CSS, .NET, right, which is actually 4 languages. Maybe they've done a few backend languages and functional programming one, and all this stuff. Then maybe the new language, they think about this being a new innovation. The .NET space, that might be adopting F# for certain projects. Maybe actually the weight in terms of that, it doesn't really necessarily need an innovation token to be spent in terms of adopting F# that team. It might be that actually you can make that measurement on whether that seems boring for that team on the basis of that weighting of their capability. So yeah, that was just the final point I thought to note. So that brings me to the conclusion. Well, that is the conclusion. So I hope that's been useful. As I said, I work for a company called Codat. We're a C# shop, as I noted. We don't have a lot of Cosmos, but we do have some now with a smaller blast radius that we've learned how to operate. And if you've got questions about what we get up to, more questions about what we get up to, feel free to ask me. And if anyone's got any questions, points, comments, like I say, I might be the guy at the front who's showing the slides, but I'm sure there are people here who have got things to add and comments to say. So even if it's not a direct question, it's just something you want to highlight or say, might be useful for other people to hear. So yeah, feel free.
Yeah, cheers, Jason. Yeah, obviously I've just seen one question come in the box already, but I had one on the tip of my tongue kind of for the last 5-10 minutes. I know that the whole premise, I guess, of the boring index is, you know, the choices or the thought process which you use at Codat. But I was running as someone who, of course, hasn't worked at Codat their whole life, and also has, you know, friends, I'm sure, of similar job titles or just knows about the industry. What mistakes do you think people make? You know, maybe areas of the index which, you know, they're considering too much, I guess, like stuff like cost. But what mistake do you think other kind of engineering leaders make when it comes to, you know, the adoption of new tech?
Yeah. I think it's the stay humble, which is that first index point. I think it's acknowledging a technology's weakness is probably the hardest thing for engineers to do. I think we're constantly thinking about this technology is new, and so it must be better because those people have been thinking that they're trying to accelerate something, some sense of velocity. And I think taking things in terms of their context, you know, that what were they trying to maximize for and what were they trying to minimize isn't necessarily the same things that you might be trying to maximize and minimize in your organization. So, you know, the canonical example, I think, with engineers is that kind of micro optimization idea, right? This kind of, oh, I'm going to do something that's using arrays rather than lists in .NET and doesn't use link because I know that using arrays is more performant. And then what happens if you actually benchmark it is sometimes actually the optimizer in .NET is way better at you than working out what exactly you should be doing at some point. It turns out that the lists and dictionaries implementation is actually way quicker than your hand-rolled array implementation. And I think that goes up to the same in that architectural level, that kind of remembering to stay humble about what you're trying to maximize and what you're trying to minimize. And being as an engineer explicitly, I mean, engineering leaders maybe you kind of will get more pressure on this, but understanding that everything we make is a business decision. It's not business and technology decisions. And so the marginal gain in velocity that you might be getting from technology might not be a global maximum. And so I think that humility is probably, I would say, the most easily missed. Yeah. In my own experience, has been.
Of course. Then, yeah, we did have one question. Of course, if anyone else in the crowd does have any, now's the time for them. But a man says he knows this kind of question can go a long way, but how else can we change the underlying perception and, I guess, peer pressure in the industry as a whole that you need to constantly be learning what's new and shiny? For example, the new JavaScript framework which came out 5 minutes ago, or everything has to be microservicing or Kafkaing, etc.
Yeah, I think separating it's so hard, right? Because the pressure is real, right? And the FOMO is real as well. I think the idea that if we didn't learn from new and shiny, if we didn't apply new and shiny, then there would be stagnation, right? And stagnation's also really bad, right? So I think it's about finding a balance between what is, you know, operationally viable for an organization versus that marginal gain piece. And I think as an industry, we probably also need to get better at learning for learning's sake at times, understanding that learning about Kafka without having to then implement it in your business the following day is actually still going to be very beneficial for you as an engineer, right? I've spent time learning and talking about functional programming, and people sometimes have asked me, like, Codat, you talk about C# all the time, but you start to talk about F# all the time. Why isn't Codat written in F#? And it was like, well, actually, if you looked at a lot of our C#, you'd think, well, it's quite functional in its approach, which is infinitely possible in C#, and it kind of informed the way that we thought about designing systems. But actually hiring engineers who are great C# devs is much easier for a business than hiring F# devs. Which means that, you know, in terms of what we're trying to minimize, what we're trying to maximize, is the marginal gain in writing the system in F#, because I love the type system, really a global maximum compared to being able to hire lots of really talented object-oriented devs in C# that are also picking up the kind of wave of functional programming. So I think I wouldn't want to distract anybody from learning on the basis of things that they're interested in. And I think maybe it's quite freeing to say that learning for learning's sake, because it will improve your general engineering understanding, rather than learning for the sake of I need to implement this in my organization tomorrow, would make people generally better engineers. And then of course you're building up that groundwork of knowledge that starts to feed into getting operational understanding for certain things, you know. And maybe the innovation token can be spent because you've said, oh, you know, we built something small, you know, using something that was maybe slightly over engineered, like the latest JavaScript framework that I read about somewhere, and then slowly feeding that in. So yeah, that, like I say, spending the token to be an early adopter or spending the token to do training, all that sort of stuff. Yeah, I think the industry as a whole, it's I guess those pressures are just always going to be hard to balance. Yeah, so does that answer the question? Maybe sort of meandering way.
Yeah, kind of does. I know I asked what mistakes do people, well, other people, you know, leaders of engineering make, but I was wondering from your perspective as someone who, you know, is the head of, you know, making these decisions, I guess. Throughout the whole index, I'm sure there's going to be different areas which are more important to you than others. So is it important for you that something kind of ticks all of these boxes, or is there one area, I guess, you know, considering you've got purse strings as well, you know, which areas are more important to you than others, would you say? Or does it go back to?
Yeah, that's tough. That's one of the reasons why, in terms of building up these points, in terms of things you would want to measure, and as an organization, I didn't want to put down an equation and put down you know, if there are 5 articles on Google that say this is a rubbish technology, that equals 3 for your index. Because I think that's disingenuous in terms of the relative experience in what those values would mean to any other organization, and the people that are working in it as well. You know, and so, you know, what do I think is most important is going to be, if you asked me, whatever is the most important limiting factors for that individual team or organization. And it takes time to select well as well. So you need to be in an organization that's willing to give you the time to make the right selection, as much as an organization that's giving you the trust to make a selection, right? Oh, we're building this new service next week. If you want to sneak in any tech projects using a new technology, then this is the time to do it. And if you're like, well, if we've got to start getting something, you know, built next week, if you're doing agile, maybe you're releasing it at the end of the sprint or whatever to start getting feedback. You know, how much are you going to be able to then say in a month down the line, oh, I think we made, over the course of this month, we've now made a bad decision, we want to rework. So yeah, I think the humility is the most important. I think that helps with you know, keeping your knowledge, keeping abreast of the knowledge that's out there and learning about what's available, but I guess not necessarily feeling the pressure that you need to constantly be using it. That it's quite often, I think, really important to be looking for what it's trying to maximize and what it's trying to minimize, and then see if that marries up with your organization. So, you know, you mentioned cost is one of those things, right? If you're a startup that's working from your own pocket, cost is going to be a massive weighting for you, right? If you just can't afford to spend to spend the money, you're going to be looking for something that's the cheapest way to run it. And maybe because of that, actually, you need to spend an innovation token on finding something that's really cheap, right? So yeah, I think in terms of those weights, it's going to depend, and I hate to give that fluffy answer, but I would say sit down. Everyone that's here, maybe you can sit down during a lunchtime with your team and say, okay, what are the things that we think we want to minimize and maximize, and what are our weights and measures in terms of technology? What do we value? What do we think is what's boring to us? And then look for places where you think you might want to maximize something, and where you might want to spend that innovation. And actually, it might be, what, I'm going to stop moaning about not using document DB, and I'm going to double down on doing SQL a little bit better, learning this a little bit more about SQL, because maybe there's still depth, right, in other places to kind of there might be technology to apply in something, a new way to apply technology that's already boring to you.
Cool. Then James, after thanking you for the session, said, as an extension to the situation you described with Cosmos DB, do you ever get yourself in situations where the firefighting becomes too much and you have to revert back to the old technology? And would it always be a good idea to implement a new technology on a smaller scale project, even if said technology is really scalable and probably even better on a larger scale? And he says he's curious because the company he's at uses this index on a regular basis.
Yeah, I always think that limiting the blast radius is really important in terms of learning operational understanding. It's one of those military quotes, right, that an army will never learn from mistakes of other armies or whatever. You kind of got to learn operations. It's useful to have people who have done those things before, but maybe somewhere else. But I think if something is somewhat new, you kind of need to learn what your operational process is going to be for any technology in an organization. I think, almost from scratch or from quite a low bar. So I think it's worth trying to minimize scope as much as you can. I think that goes to implementation, right? The more you try to implement, same as any other agile process in terms of scope, right? The more you try to implement before the point of release date, the more variables you're going to have in terms of things that may or may not be right in the way that you're using a set technology. So yeah, I think limiting a blast radius is super sensible, but it's not always possible. There may be something that just by its nature covers a lot of bases. Maybe there's something in your network stack, right, that you kind of need to implement, and it's like, well, the way these systems are deployed, it's kind of, we've got to go all or nothing. It's just you got to be willing to try and pay off some of those costs for making the technology boring, maybe before it ends up being in production in some other way. So even if the deployment to production is quite large, maybe there's a small scale in terms of your learning how to operate something beforehand, with spikes and stuff like that, to kind of make the technology more boring.
Cool. Well, I think that's the last question, unless anyone else is typing something as I'm talking. Yeah, well, there we go then. From Rick, he says, from past experience, you sometimes have a technical architect that wants to use a new tech because they want to enhance their own technology or just enhance their CV rather. This has led to some.
Codat talking about me with his false name.
Apparently, this has led to some disastrous outcomes. For example, in maintenance of costs, in both cases, the technical architect left, and the situation becomes quite serious.
I think these sorts of, like, this is pretty toxic culture, right? I think there are two things you can do, right? Scott Hanselman quote: you either change the company or you change your company. So if you feel like you can impart pressure and understanding, raise awareness from the bottom up about technologies and their application and architecture particularly, right? Because everyone is an architect, no matter what job titles say, whether you're architecting the shape and form of a single class, a multiple set of classes, or a whole bunch of services. Everyone's really an architect, and and so if you have those sorts of situations, you're placing a bet, someone making a top-down decision, placing a bet on the ability for the individuals they're dumping it on to operate it. They may be resting their own, they may be accepting some liability, but you're still the one that's going to be caught out. And I think in those sorts of situations, yeah, you have to make a decision about whether you feel you want to spend the time changing the company or changing your company. Like, come work for Codat. But that's I think that's very familiar, and I think that it's important to know that technology is chosen, or there's a big emphasis in getting a hand in the technology being chosen by the people who are going to operate the technology and use the technology and implement the technology. Those sorts of top-down things, maybe sometimes they're necessary. When Codat started, we said we're going to use C#, and we didn't then say .NET, which I guess was a top-down architectural decision. So they did, it sometimes happens, but yeah, I think that happens often, right? That kind of disastrous outcome of those sorts of top-down things.
Cool. Then yeah, one more from Aman, who I should say hello to, seeing as I've been speaking to him about potentially getting him on one of these talks in the future. He said he largely agrees that in solving problems in a simple manner as possible is usually the best way to go. New tech is not a silver bullet, but I also think the right tool for the job is important. Forcing a tool to do something it wasn't designed to do is also going to impact velocity and maintenance effort. For example, forcing an incompatible data model on a data store that it wasn't designed to simply due to familiarity. Do you agree?
Yeah, I that right tool for the job, I think, can be used in two guises, right? It can be a positive and a negative consequence. Again, I think you're right. If you are really trying to twist something in a way that it should never have been used, you're probably going to be incurring some cost, some uphill battle for that. I think a lot of the choices that we make in technology, we're gifted these days, certainly with persistence store, and it's one of the reasons why that's the sad story I use. I think it's the most familiar that I've seen in other organizations, right? It's that hot swapping persistent stores because it's the right store for the job. Actually, a lot of them kind of can do most of it in a way that's decent enough. And then you're really looking for, really, if that is absolutely the bottleneck for your business to be able to make revenue, is the fact that you're using CouchDB rather than MongoDB, then I think that sounds like it's a very hard point to get to. But maybe then it's worth spending that innovation token to learn and find out about how to make Mongo more boring to you as an organization. But generally, most times when I come across those things, it's new and shiny, and a lot of tools at their initial implementation, when they've been used, have been picked for some reason. I guess that getting to the point of using something that it wasn't ever designed to do maybe implies that you were making a bad decision in the first place. You picked the wrong technology at the beginning, which maybe is, if that's a legacy, right? That's something that you've inherited. You've been using the file system instead of a database or something, and you're like, oh, querying is really hard because we have to do folder searches with grub string or something like that. Yeah, okay, well, it sounds like you're using the wrong technology, but if it's, we were using MySQL and I think we should be using Postgres, that's, maybe that's a harder thing. But so yeah, I think it's worth, always when that phrase is used, is worth drilling into those reasons around what are you trying to minimize, what are you trying to maximize, what are the positive and negative consequences of the suggestion. Because yeah, like you say, it's not always a panacea. Yeah, new technology. Agreed.
Cool. Yeah, I think that's it. I know conversations like this in regards to picking new tech can go on for ages. I mean, I'd love to share this with some of my clients who decided to go with Ruby and all these really fucking hard to fill jobs, which makes my job really difficult. But on that topic, you mentioned, if you want to follow this kind of index, come work with you guys. Are you you're, well, I think you're always hiring really for good .NET people, aren't you?
Pretty much always hiring for good .NET people. Yeah, absolutely. We do TypeScript on the front end as well if people are into React and things like that. We hire specialists in .NET for back end stuff and front end, but full stack as well. We've got space for sometimes. Yeah, come and talk. And if people want to carry on the conversation, more than happy. Shout at me on Twitter or something like that at JasonDS. And we can carry on arguing or discussing or sharing. You're really interested to hear people's opinions. Thanks for your questions and points.
Yeah, cool. So yeah, thanks everyone for the questions, and yeah, thanks Jason. Yeah, as he mentioned, you can find him on Twitter, and of course Codat are always very busy looking for new people, so I'm sure you can DM him your CV. But yeah, thanks everyone for coming. As I said, we're gonna have a little bit of a hiatus from now until the next one. The next event will be sometime in July, where I'll be announcing a new round. But yeah, thanks again, Jason, and yeah, we'll see everyone in the next one.
Cool.
Cool. Cheers, guys. Thank you. Bye.